Wade.
Hey, Carly.
Today, we're going to go ahead and talk about my favorite thing in statistics.
Your favorite thing?
My favorite thing, which is called the normal curve. And the normal curve, if you've heard of it, is I like to think of it as an ideal bell-shaped histogram. So it looks, if I was going to draw it, it looks like a bell. It's nice and symmetrical, and it looks like this. And you might be wondering, why do I care about this thing? Why do I like it so much? And the reason I like it is because a lot of histograms actually resemble the normal curve, right, Wade? Doesn't this kind of appears a lot?
It does. And I feel like every time you do a lot of simulations, you sample from the simulation, you always end up getting a normal curve if you're adding samples together.
Exactly. So we're definitely going to dive more into that. But like Wade said, the normal curve appears a lot. A lot of data is what we call normally distributed. And so the nice thing about the normal curve is that we can use it as an approximate histogram for data that's normally distributed. So if we think about IQ scores, for example, IQ scores in general are a data set that is usually normally distributed, centered around 100. So that's the average IQ score. And we looked at how to draw histograms and calculate what's the probability that someone has an IQ score lower than 90 or someone has an IQ score above 105. And we would actually have to go ahead and draw the histogram, whatever it looked like, and then find the areas of these bars. And that's how we would find these probabilities. But that takes a while. And Python can help us. We can create histograms in Python. But the nice thing about the normal curve is that we can use it. If we know the data looks roughly normally distributed, we can use it as an approximate histogram. And this is called the normal approximation. And there's a couple things to know about using the normal approximation. And the first is that whatever data we have is probably going to have a certain type of units. So like, Wade, do you know any other variables that tend to be normally distributed?
So I've heard the height of men or the height of women, each of them independently, are normally distributed. Like the average woman is like 5 foot or 5'5",
5'4", I think something like that. Yes, that is definitely a good example. Heights, and usually you'll see data with heights in inches, or like you gave feet in inches. And the normal curve is if the histogram looks roughly like this, we can use the normal curve. But the problem is our data for heights is in inches, and the normal curve actually isn't in inches. So what we can do is use a special version of the normal curve called the standard normal curve, where the average, we can convert the average to be 0 and the standard deviation to be 1. And then we can use this normal curve to calculate areas. So we could figure out, like, for heights, for women's heights, I'm 5'10". I'm pretty tall. So I could figure out what percent of women actually are shorter than me or taller than me using this standard normal curve. And I'd have to convert my height into something we call standard units, or z-scores.
So the average of the curve, is that going to be the center point? So if we were to draw a standard normal curve, it would have a different center point, wouldn't it?
Exactly. So the standard normal curve can be used for any data. No matter what the units are, we can always convert to standard units. So the standard normal curve, we said, always has an average of 0 and an SD of 1. So I would need to figure out, as someone that's 5'10", how many standard deviations away from the average am I? And then I would mark that on the normal curve, and I could find the different areas. So we're going to dive a lot more into this, but one thing to note as well is that the standard normal curve has a nice table attached to it that tells us the areas below each of the standard units. And we can also do that same calculation in Python.
So you talked about area. Why do we care about the area of a curve? Is there something special about the area of a normal curve?
So the area of the normal curve actually tells us what percent, so the total area is 100%. And we can figure out sections of the normal curve, and then we can answer questions about the data. Like for the height data, I could answer if my height ends up being right here, I can use the area to figure out what percent of women are taller than me.
So that's a pretty small area, especially because it gets narrower. So that may only be 5 or 10% of all women are taller than you and 90% are shorter.
Exactly. And we can, again, use the table associated with the standard normal curve or Python to calculate this exact area.